Okay, so let's start our lecture today. So, uh, okay, so we're gonna show that, uh, uh, okay, so we're gonna show that e to the ln converges locally uniformly to e to the l on k. Okay. Let's see. So, okay, so let's erase that. So why this is true? So, so basically, I feel like the idea is that, so what do you want to use? Okay, so we want to set up an argument like that, right? So basically what we want is that, so basically, if you take the for n large, right? Capital N large, we want to say that the e to the ln z and z in k, of course. Okay, so for n large and z in k. Okay, so we have that e to the ln z minus e to the lz. Okay, this one we want it to be small, right? So the way that we make it small is that, I think there's a lemma that I used in the past that, so here there's a lemma that I want to use. Okay, so let me just erase that. So I want to say that state a lemma first. So yeah, so let me just recall what is the lemma. So let's see. So yeah, so this is still loading right now. So oh shit. Okay, here we go. So let FG so from okay, so here we go. So okay, so that K star in C be a compact convex set. For convex set, basically we can think of the closed disk, and that H be a holomorphic function. H be holomorphic. On an open set. Containing K star. Okay. So if UV are maps, with U of K union V of K. So this is set union. So I shall use this letter for U. Okay, so this is U of K union V of K. Is contained in K star. Okay. For some compact set K. K in C. Then we have that the supremum of Z in K of the modulus of H composed with U of Z minus H composed with V of Z is less than or equal to L of H on the set K star times the supremum of Z in K of UZ minus VZ. Okay. So this L means the so where so this L means that L of K star, sorry, is being defined as the supremum of Z in K star of the modulus of H prime Z. Okay, so basically it is a first degree bound for this H on the set. It's the first degree bound of H on the K star. Okay. So here so yeah, so So for this one, basically, the proof actually involves just like a line integral, right? So basically, for any z, you take the line, because this for any z, this uz and vz, both of this set is contained in the set k star, right? So therefore, and also this k star is a convex set, so you can take like the line adjoining this uz and vz. So and then then after that you have that so you use the fundamental theorem of line integral. So you write this h of uz. So 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 modulus of h of uz minus h of uz minus h of vz, which is equal to the line integral of h. So the line integral taking over the line that adjoins this uz and vz, right? So I'll use the line gamma to be the line that adjoins this uz and vz of h prime z dz. Okay. Yes. So yeah. So basically, you just set it to the yeah. So let me check this one. So this is equal to the integral of, so t goes from 0 to 1, right? And then h prime of gamma t times gamma prime t dt, right? So which is where this gamma prime t is just uz minus vz, right? So gamma t basically is equal to so vz times plus t times uz minus vz. Okay. T equal to 0 is vz, t equal to 1 is uz. Okay. So gamma prime t, which is just the uz minus vz, right? So which is equal to integral from 0 to 1. H prime of gamma t times uz minus vz, right? dt. Okay. Yeah. So so this is true by the fundamental theorem of line integral. Okay. So yeah, I was okay. By the fundamental theorem of line integral. Okay, so yeah, so this is true by fundamental theorem of line integral. Okay, so yeah, so maybe here I'll add another simply connected. Okay, because I think the fundamental theorem of line integral requires simply connectedness for the domain, right? Okay, so so if I have it is simply connected, then yeah, so this is path independent. Wait, I don't. So okay, so I think I messed up here. So let me check the. Okay, so maybe I'll leave as an exercise to check this one. So yeah. So exercise using fundamental theorem of line integral. Okay, so yeah, so now we have that. Because after we take the modulus of this guy, right? So the modulus of this guy is h of uz minus h of vz, which is less than or equal to the line integral from 0 to 1, the modulus inside, right? H prime of gamma t dt times the modulus of uz minus vz, because this is like a constant term, so we can pull it out, minus vz. So then, this is equal to, so this one is just so this one is less than or equal to, so this is integral from 0 to 1, and then this thing inside is bounded by this L, right? Less than or equal to L of h k star and times the modulus of uz minus vz, right? So this is less than or equal to this L times the taking over the supremum, right? Of this uz minus vz. Yeah, so this is like an upper bound for modulus of huz minus hvz. So therefore, after take the supremum of this huz minus hvz, we should also be less than or equal to this guy. So we have this result. So yeah, so yeah, so this is equal to what? So the idea is that so here we need to find some so here what we want is that we want to find some Okay, so in order to use this argument, so we need is that, so it's less than epsilon. Okay, here, so here what we need is that, so here, so this is what we need. So find so we need to find like a k star, right? So basically, one condition to use this upper bound is that this uk and vk. So basically, this k is like this k, right? It's the same k. It should be the same k. Okay. So and then what we want is that because we want to show that because we hold on. Yeah, so what we want is that we want for each n, we want to apply this argument for this u as this lnz, right? The v as this lz, and this h is like the exponential function. Okay, so this is what we want. So so basically, in order to do that, so I want to find like a k star. Okay, so find this compact convex simply connected. Okay, so find this k star satisfying. So k star compact convex and also simply connected. So simply connected. Okay, so I don't think this simply connected is a necessary condition for this one, but I think it is related to this fundamental theorem of line integral. So I'll double check that maybe later. Okay. Such that okay, so ln of k union and ln of k is contained in this k star for all n, and also L of k is also contained in this k star. Okay, so if we find that, then we can use because the limited upper bound is being fixed, and then this supremum will goes to 0, right? As this n goes to infinity. So because we know that this u and v, which is the same, which is represented by ln and lz, will be closer and closer to each other, so that this term will goes to 0, and this is a fixed term. So after we show that, we are done. Okay. Yeah. So before I do that, let me just quickly check the fundamental theorem of line integral. So let me see what is the condition to use that. Okay. Okay, so maybe I think I'll just check it afterwards, and then I'll just come back later. Okay.